One trough of water, one vast lake, one tiny pebble, one massive rock. Different sizes, different weight. What connects them all? Not in shape, not weight, but something more fundamental, something that defines what they're made of. Density. What's density?
First, let's visualize density. At a micro perspective level, these rocks represent the particles that make up any material, such as atoms or molecules. Density tells us how tightly these particles are packed together. For example, two objects made of the same material but in different sizes have the same density because the particles are packed similarly but in different amounts. Okay, so this explains why a small rock and a big rock feel different in size but have the same density. Importantly, density is not just about size or weight alone. It is a characteristic property of the material itself. Density shows the connection between mass and volume in any given substance. Mathematically, density equals mass divided by volume, where mass is the amount of matter in an object, usually measured in grams and kilograms, whereas volume refers to the amount of space an object occupies, measured in cubic centimeters or liters. A common misconception is that heavier or larger objects always have a higher density, when in fact, size and weight don't always determine density. For example, a huge piece of wood weighs more than a small rock object, but has a much lower density because wood particles are less tightly packed.
Hi, let's talk about the history of density. The concept of density originates from the ancient time where the mathematician and the physicist Archimedes discovered a way to measure an object's volume by observing the rise of water when the object is submerged. From this, he realized that density is the ratio of an object's mass to its volume, helping to distinguish genuine materials from fakes, as in the story of the Golden Crown. Over the century, density was clearly defined in modern science as a fundamental physical quantity, playing a crucial role in understanding and applying the properties of matters. From solid and liquid to gases, in many fields such as engineering, medicine, and the environment.
Hi everyone, my name is Hui. Let's talk about the application of density. Density, as you may know, play a crucial part in many aspects of life and science. Well, why do some objects float while others don't? Take woods and rocks for example. Wood floats because its density is less than water. Rocks sink because its density is much greater. Engineers have chosen material to form structure that are strong but also very lightweight. Let's use water bottle as an example. As you can see, it's really hard to tear apart, but it's also very lightweighted. So, density is truly the key property to create product, to identify material, and finally to explain natural phenomena.
As Balsalm mentioned before, the objects made of the same material have the same density. So we're gonna demonstrate this by creating a simple experiment. First, we're gonna measure the mass and the volume to determine the density. This will show that even if they're in different sizes, the density of the material remains constant. Now, we will take the experiment to Quantum where Quang Bảo will show you guys how to correctly experiment.
In the experiment, we need two required equipment. The first equipment is the digital kitchen scale, capable of measuring mass to within 0.01 gram. And the second one is the measuring cup. We'll test four materials: natural rocks and broken bricks with irregular shapes. Water is used both as a liquid sample for density determination and as the medium for water displacement. Oil is a liquid sample with distinct density characteristics different from water, measured by volume in a graduated cylinder.
There are two types of state of matter we will conduct experiment with: liquid and solid. For liquids, the first subject is water. We will experiment with the liquid subject twice, but in different volumes and masses. Foremost, we weigh an empty measuring cup and reset the scale to 0. Then, we will pour a set volume of liquid into the cup and record its mass. Using the known volume, first we pour 500 milliliters with 483 grams, and the second is 700 milliliters with 676 grams. Same with the procedure for oil. Reset the scale to 0 and pour the oil for the set amount. In our case, at 100 milliliters and 200 milliliters, respectively, corresponding to 68 grams and 150 grams. Opposite to liquids, we weigh each piece of solid first to find its mass, where two different irregular rocks from our group have masses of 169 grams and 323 grams, and these broken bricks have masses of 317 grams and 232 grams. Then, submerge it in water inside a graduated container to measure the volume of water displaced. This equals the volume of the object, which 323 gram rock has a volume of 135 milliliters, and the 169 gram rock has a volume of 60 milliliters, whereas a 232 gram brick has the volume of 100 milliliters, and a 317 gram brick has the volume of 150 milliliters. Once mass and volume are known, we apply the formula density equal mass divided by volume. This allows us to calculate the density of each sample. However, Bao and I need time to calculate and write down all the result. In the meantime, while waiting, let's take a look at what Dang, Nhung, and Tam are doing behind the scenes when doing the reports.
In the meantime, while Wong and Bao are calculating the final result, Nhung, Tam and I are doing a photo shoot of our experiment equipment, the materials for our group report poster. Look, we repair all of the materials, set up the camera, and shoot. Bang. Oh, Wong just called me and he said the result from the experiment is finished. Wong, please take it away.
Let's see together if the result of each material have the same density when they're both different in mass. So, our experiments confirm that the density of each material remains constant, no matter the sample size. Therefore, density is an intrinsic property tied to the material nature, not size or weight. From a single water droplet to the vast lake, from a tiny pebble to a massive lake, density connects them all. It helps us understand the true nature of matter, what things are made of beyond their shape or size. Density, one property, one identity.